What's up, guys? It's Luke here. I just wanted to do a real quick tutorial on basic programming because I've been getting a lot of emails for programming help and just with basic programming questions. And so I decided it would probably be best to just clear up a lot of these by doing an in-depth series of programming tutorials as far as I know. Now, I know I don't know everything. I'm definitely not anywhere near Jay Pearman or some of the other people on the forums. I'm not a professional. I may use terms, actually I probably will use terms at some point incorrectly, but I know that at least some of the basic concepts that I'm going to show are correct and that they will make things a lot simpler. So I'm going to do my best to make this really easy to understand, very clear, and just work through this so that everyone can understand this. I'm going to start at a really basic level so that no one is left behind. And I'm gonna try to clear up some stuff for especially people beginning in RobotC and make it so that programming is not only something that you can do, but you actually enjoy doing. Because I started last year and I thought I was gonna hate it, and at first I really did, but I pushed through that and I really enjoy it now, and I'd like other people who currently hate it to eventually be able to enjoy it. So anyways, first of all, what we're gonna do is we're going to start this as though we are just starting programming for a new robot. So what you're going to do is you're going to go to File, New, then Competition Template. And again, this is also for RobotC 4.0. So if you do not have 4.0, this is not going to make sense. So what you're going to do is go to Competition Template. You're going to see this file here. You're going to want to save. I won't, because I already have a lot of code files for Aftershock on my computer, but and I don't need extra files. But here is what you're going to see. Now, what you're going to see here in this section is pragmas. Those you do not want to mess with, as it says there. Do not mess with actually any of this. It doesn't say it yet because you haven't generated anything, but it'll display that warning here in just a moment. Here you have pre-autonomous functions. This is stuff that will run before autonomous runs. Then you have down here autonomous, so you can put autonomous code in there. Then down here you have your user control, which I will do a tutorial on this, but like I said, this is going to be really basic and mostly concepts today. So the first thing you're going to want to do after getting your competition template is you're going to want to go up to Robot, down to Motors and Sensors Setup, and then you're going to want to trace through your entire robot, all of your motors and everything, all your motors, all your sensors, and get them all labeled, because it makes understanding your own code and other people trying to understand your code makes it a lot easier for them. It is so annoying to try to even write code for yourself, even when you know it all, if you do not do this, because it makes it so much more difficult to understand. Also, if you forget what wires are where, it's just a pain in the butt. So what you're going to want to do, let's say for this example that port 1 is the left side of your drive. Actually, let's make this a four motor drive. So let's say this is left front drive, this is left back drive. Let's say this is the right back drive, and let's say this is the right front drive. Now, these are all 393s, high speed, because we like speed. Speed is awesome. And then now if you need to reverse some of your motors because they're going backwards or whatever, you just click that, then you'll hit apply. But if you don't need to reverse anything, then and here you can also assign this, but you don't need to worry about this because we're going to program this up all ourselves. We're not going to use what RobotC already gives you, because if you understand how to do it for yourself, you are able to do so much more, and able to have a lot more control over it also. So moving right along, hit apply. Do not hit OK. If you hit OK, it will not save. It is so annoying. Hit apply, then you hit OK. So now you'll see up here it has generated some code, pragmas, more pragmas, just like those. Now you'll also see code automatically generated. Do not change that. Just don't. It does not end well. it confuses RobotC, and it's easier to just go into the wizard anyways. So port 1 you see is the left front drive, VEX 393 high-speed motor, port 2, left back drive, etc. So what you're going to want to do for, say, just a simple basic driving function is you could do it just here in task autonomous, but that's so much more complicated. So what you do instead is you come up here to right here, make yourself a little bit of room, and then let's just add a comment line. So drive functions. Now what you're going to do is type in a special word, no caps, special word, the word void. Now when the computer sees this word, just like the word #include or #pragma, the word void, it recognizes as being special. What it does is it realizes that the next word you type in, so say drive, is something special in and of itself, something that it has to reference anytime you put in the word drive. Now, something about syntax, the word void, the name that you define, then you're going to put an opening, closing parentheses, and then opening and closing curly brackets. Now, in here, you can define variables. In here, you're going to define code that gets run every single time that you reference the word drive. The word variables in here, the variables that you might define in there can then be referenced within this code, but they are defined when you reference this word later on. So for instance, I'll get to that in a second, but for now, let's declare an integer, int, another special keyword. Let's say speed, and then integer distance. Or actually, no, we won't get into sensors yet. Let's do time. So in most of RobotC, the first learning curve really is the syntax. So to define a motor speed, what you're going to do is you're going to go into, actually, wait a second. In order to reference names that you put in there, you're going to want to compile the code real quick. So hit F7, and it wants me to save, so I will just save that on my desktop, even though I don't really want to. And here we have, if you then go and type in motor, and then square bracket, has to be a square bracket, you got to get all your brackets right, you'll see that now left drive and all of those show up, and that makes it so much easier. So now you're going to put the speed equal to the variable that you already defined. So there you have it already for you, does it all nice and for you, plus it makes it way more flexible than having to have a million different functions, one for each different motor speed, etc., or each commonly used speed. And so there you have this. Give me a second to type it. Don't want to get some caps and not. For one thing, it's bad programming. For another, it doesn't look good, and it's just not a good idea. So anyways, so there we have that. So now when you define a motor speed, it's going to maintain that speed until you tell it to do something different. Essentially, whenever you tell something to happen, it's going to continue to happen until you tell it to do something different. So what you can do here is how do you stop it then? You have to do motor, and then actually I will just copy and paste all this, because hey, doing programming doesn't mean that you have to work hard at it. Might take some time, but it does not mean that you have to work unnecessarily. Okay, so I've told it to now stop, but how do you make sure that it goes for the amount of time that you want it to go? Well, RobotC's given us a nice little function. So you can type in wait 1 millisecond or wait 1 capital M sec. Now, if you put then on this for the syntax just regular brackets, nothing else, you can put in a time. So put in time, and then always remember to put at the end of all your lines of code, except for when you're defining a function or something, always remember to put your semicolons. This will screw up your code if you do not have these little guys. It's annoying, but it's necessary. It helps you out even though you don't really realize it. So anyways, so it will drive at that speed that you define when you reference it until for the amount of time that you tell it to, and then it will stop. Now, how do you do this? If we go down to autonomous, what you can do is put in here drive, can't type today, for, let's say full speed, 127 for 1 second or 1,000 milliseconds. Now, what it will do is you have defined, and it must be in order, the first variable you defined is the speed, second variable is the time. So you see here, first variable is speed, second variable is time. So drive for at 127 speed on all your drive motors, then wait for 1 second before you then stop all the motors. So this is how you can get a basic drive function. And yeah, functions, they're kind of difficult to understand, but you should know them from high school math. Not sure when they really get introduced first, at least the concept. It depends on the curriculum. But functions in programming are exactly like math functions, except with executing code instead of with numbers. So anyways, thanks for watching. Don't forget to like the video and subscribe if you're new, and check out some of our other videos that we have up on our YouTube channel. So anyways, once again, thanks for watching, and see you next time.